A task that a computer can complete in a few hundred seconds would take the world's fastest supercomputer 10,000 years. That's right, 10,000 years. And this is the feat of Zuchongzhi 3, which was recently unveiled by China. Hello everyone, and welcome to Volt China. Today, we're going to demystify this quantum computer whose computational speed crushes that of Google and IBM. Just how powerful is it, and how will it change our world? I know what you're thinking right now. Is this real? Yes, it's very real. And what's even more astonishing is that this machine has outperformed tech giants like Google and IBM by a significant margin. Let me break it down for you in the simplest way. What exactly is quantum computing? The computers we use daily are pretty straightforward. They think in binary terms, either yes or no, represented as 0 or 1, right? But quantum computers? They're like having a cheat code. They can say yes, no, maybe, and probably, all at the same time. This phenomenon is called quantum superposition. Sounds mind-boggling, but the results are absolutely terrifying in terms of computational power. Let me give you a quick calculation. One quantum bit, qubit, can represent 2 states, 2 qubits can represent 4 states, 3 can represent 8 states. When you get to 105 qubits, how many states are we talking about? 2 to the power of 105 factorial. That's a colossal number with 32 digits, larger than the total number of atoms in the universe. This is why quantum computing is so revolutionary. So, how strong is China in the field of quantum computing? Here's a quick timeline. 2020, China unveiled the Zhujiang photonic quantum computer, shocking the world. 2021, Zuchongzhi 2 was launched, continuing China's dominance. 2025, now, Zuchongzhi 3 has arrived. Here's the crux. China is the only country globally to achieve quantum computational supremacy using 2 distinct technological approaches, superconducting and photonic quantum computing. What does this mean? It's like someone winning Olympic gold medals in both swimming and track events. In contrast, US companies like Google and IBM have only made strides in superconducting quantum computing, but China has mastered both paths. Now let's take a closer look at the terrifying capabilities of Zuchongzhi 3. 105 qubits. While it may not sound like a lot, every additional qubit exponentially increases the difficulty of maintaining system stability. It's like orchestrating 105 world-class dancers simultaneously, ensuring not a single mistake occurs. 72 microseconds. This is the coherence time, the duration for which qubits remain stable. Don't underestimate these 72 microseconds. In the quantum realm, this is already an incredibly long time, sufficient for thousands of complex quantum operations. 99% precision. Out of 1,000 operations, fewer than 10 errors occur. This level of precision meets the requirements for practical applications. Millions of times faster. Zuchongzhi 3 is millions of times faster than the most advanced supercomputers. Tasks that would take supercomputers 10,000 years can be completed in mere seconds. Now, for the most exciting part, how does Zuchongzhi 3 crush its competitors? First, let's compare it with Google. Google released its latest quantum chip, Willow, in 2024, which seemed impressive at first glance. But here's the reality. In quantum random circuit sampling tasks, Zuchongzhi 3 is 1 million times faster than Google. In terms of quantum supremacy, Zuchongzhi 3 achieves 10 to the power of 40, while Google only reaches 10 to the power of 25. That's a difference of 15 orders of magnitude. Next, IBM. IBM boasts its quantum processor with 433 qubits, which sounds like a lot. But here's the catch. Quantum volume matters more than the sheer number of qubits. Zuchongzhi 3 achieves a quantum volume of 10,240, while IBM only reaches 4,096. Precision? Zuchongzhi 3 boasts 99.62%, while IBM lags behind at 97.93%. Most importantly, Zuchongzhi 3 has achieved true quantum supremacy, while IBM has yet to reach this milestone. It's like comparing a Ferrari to a tractor. How did Zuchongzhi 3 achieve such extraordinary capabilities? Extreme working conditions. The entire system operates at temperatures close to absolute zero, colder than outer space by 1,000 times. In this ultra-low temperature environment, electrons form special Cooper pairs, enabling resistance-free flow. Dual-chip flip architecture. The research team stacked 2 chips together, one for qubits and the other for control. This design solves challenges like complex wiring and heat dissipation. 2D grid architecture. 287 qubits are meticulously arranged in a grid, optimized specifically for future quantum error correction. What can this technology revolutionize? Drug development. Developing a new drug currently takes 10 to 15 years and costs billions of dollars. With quantum computing, molecular simulations that once took years can now be completed in days. Breakthrough treatments for cancer and Alzheimer's could emerge much faster. Materials science. Room temperature superconductors, more efficient solar cells, and lighter, stronger materials. Things once confined to science fiction are now within reach. Finance. Zuchongzhi. 3 can perform financial modeling in minutes, tasks that traditional computers would take months to complete. Portfolio optimization, risk assessment, and high-frequency trading will all be revolutionized. Artificial intelligence. Quantum machine learning will propel AI to new heights, transforming image recognition, speech processing, and natural language understanding. Quantum error correction is the key to making quantum computing practical. Why is error correction needed? Because qubits are incredibly fragile. Imagine writing on paper while someone nudges your hand. Your writing would skew. Quantum error correction uses multiple physical qubits to encode one logical qubit, like creating backups. Zuchongzhi 3 employs the surface code algorithm, with experiments on a code distance of 7. This requires 49 physical qubits to encode one logical qubit. While it may seem wasteful, it greatly reduces error rates. Once quantum error correction matures, we can build large-scale, stable quantum computers. Zuchongzhi 3's success is driving the development of China's quantum computing industry. A quantum computing cluster centered in Hefei is taking shape, including institutions like USTC, Quantum CTech, and Origin Quantum. Cities like Beijing, Shanghai, and Shenzhen are also actively investing in quantum technology. This integrated approach of academia, industry, and research provides strong support for quantum computing commercialization. According to the research team, within 3 to 5 years, China aims to control over 1,000 qubits, and within 10 to 15 years, practical quantum computers will become a reality. At that point, tasks requiring decades to complete today, like cracking complex encryption, could be finished in minutes. Drug development timelines could shrink from 10 years to 1 year, and AI capabilities will experience transformative leaps. Zuchongzhi 3's success is not just a technological breakthrough, it reshapes the global tech landscape. In traditional computing, the US has long held dominance, but in quantum computing, China has achieved technological leadership. This means China will have greater influence in the future of computing technologies. Moreover, quantum computing requires an entirely new industrial chain. China's leadership provides an opportunity to build an independent, controllable supply chain, reducing reliance on foreign technologies, a significant strategic advantage. Friends, today we are witnessing a historic moment in the world of technology. Zuchongzhi 3's success marks China's leading position in the global quantum computing race, humanity's major progress in quantum technology exploration, and the beginning of the next computing revolution. With 105 qubits, 72 microseconds of coherence time, 99% ultra-high precision, and millions of times faster computation, these jaw-dropping figures represent the culmination of Chinese scientists' wisdom and relentless efforts. In comparison with international advancements, Zuchongzhi 3 showcases comprehensive technical superiority. Not only does it lead globally in key performance metrics, but it also paves a realistic path toward practical quantum computing. Looking ahead, quantum computing promises revolutionary changes in drug development, materials science, financial modeling, and artificial intelligence. We stand at the dawn of a new era. Zuchongzhi 3's success not only demonstrates China's technological prowess, but also makes significant contributions to global quantum computing development. As technology continues to advance and applications deepen, Quantum computing is poised to bring about a new technological revolution in the near future. If you want to learn more about China's breakthroughs in tech innovation, don't forget to like, subscribe to Volt China, and turn on notifications. Share your thoughts in the comments. Which field do you think quantum computing will first achieve transformative applications? Medicine, materials science, or AI? We look forward to hearing your predictions. Next episode preview. We'll dive into China's latest advancements in 6G communication technology and brain-computer interfaces. You won't want to miss it. See you next time.